Okay, so now we're in section 4.8, antiderivatives. Antiderivatives. And you've seen these a little bit. You have. So what are these antiderivatives? Well, an example, a physicist who knows the velocity of a particle might wish to know its position at a given time. Okay, an engineer who can measure the variable rate at which water is leaking from a tank wants to know the amount leaked over a certain time period. Okay, another example is a biologist who knows the rate at which bacteria population is increasing might want to deduce the size of what the population would be at some future time. Okay, so I mean that's a very good example, the biology example. Biologist knows the rate at which the bacteria population is increasing. Then the biologist would want to know what's the size of the population at some future time. Well, in each case, the problem is to find a function f whose derivative, a function capital F, whose derivative is a known function little f. And if the function capital F exists, it's called an antiderivative of f, an antiderivative. Okay, so antiderivatives are extremely important in chapter 5, and you'll be doing a lot of antiderivatives in calculus 2 as well. So I think it makes sense to start off with a little picture here. This picture in figure 1. Okay, so in figure 1, they have what's called members of the family of antiderivatives for f of x equals x squared. Okay, for f of x equals x squared. And it's sort of a, I mean, like, well, they have y equals x cubed plus 3, y equals x cubed plus 2, y equals x cubed, I'm sorry, they have y equals x cubed over 3 plus 3, y equals x cubed over 3 plus 2, y equals x cubed over 3 plus 1. They have all these antiderivatives. They form a family. Okay, so an antiderivative is not unique. An antiderivative is not unique. So let me show you why this figure 1 is true. Okay, let me go ahead and bring up the whiteboard and write down the f of x equals x squared. So this is to support figure 1 from section 4.8, antiderivatives. Okay, now this big f function we call it the antiderivative. Kind of amazing. You've been learning derivatives this semester in calculus 1, and now you want to know about an antiderivative. All right. So this notation, capital F of x, means the antiderivative of your function f of x, your little function f of x. And I can tell you that the antiderivative here for our little function f, which equals x squared, the antiderivative is going to be x cubed over 3 plus a constant. C could be any constant. It can be any constant. It's also known as constant of integration, but we won't, get into that just yet. But, you might wonder, well, why? Why is the antiderivative of our function equal to x cubed over 3 plus a constant? Why is that? Well, let me show you why. If you take the derivative of the antiderivative, that's what I'm doing here, derivative of the antiderivative. That's the derivative of x cubed over 3 plus that constant. The derivative of the sum is the sum of the derivatives. So the derivative of x cubed over 3, we can factor the x cubed out. And the derivative of x cubed by the power rule is just 3x squared. What's the derivative of a constant, by the way? What's the derivative of a constant? 0. So you're going to get back, thank you, Sebastian, thank you, Joe. You're going to get back, thank you, Rodrigo, you're going to get back x squared. And x squared was your little function f of x. That's why we call the capital F of x function an antiderivative of our little function f. Because the derivative of an antiderivative gives you back the function. Okay, is that clear? Are there any questions on that? Who feels comfortable with that? Okay, Yaki's comfortable, good. Nicholas is comfortable. Joe's good, all right, good. Zoe's good, all right. Are there any questions? Well, then based on this, let me just go back to the picture here real quick. Let me go back to the picture now that we know the antiderivative of our function x squared. Now, hold on. Yep, that's what we want. Now the picture makes sense. Okay, so because of that constant of integration in the antiderivative, there are a lot of members, a lot of antiderivatives. So y equals x cubed over 3 plus 3. 3 is a value of c. Y equals x cubed over 3 plus 2. 2 is a value of c. There's a family of antiderivatives for the function f of x equals x squared because of that unknown constant, c, that you just saw. Okay, c is a constant. It could be any number. And that generates then a family of antiderivatives for your function. All right, are there any questions on that? All right. Well, I will stop the recording.